So you see the position of the person as this, I guess, director of the model, the director of the AI system, rather than uh, th- there is this, as we talked about earlier with the idea of vibe coding, there is this idea that floats around where at some point you fully replace the human in the equation and you just let you let the model go off and do everything by itself. There's been these experiments where you've let these AI models go and try to build a web browser by themselves, and they can somewhat approximate it, but you see the position of the human in the middle here as someone who can keep this system organized into a logical infrastructure that is actually able to be extended, I guess.
Yeah, I think you're asking a very important question here. So the thing I kind of didn't even mention is why we need the human there at all. And so as soon as we need the human in the picture, the human will need the logically organized system. Because it's our need. Like why we have the engineering discipline at all is because we as humans need it. Right. So, but the question is like, why do we need humans there? And there are a bunch of different sort of angles at this. One is that, you can tell a model to build a browser because it's very well known what a browser is. We have existing browsers, we have standards that describe what browsers do, we have benchmarks, we have tons and tons of things that define what a browser is. You say one word and we know what it is, and the model knows what it is because it has this public knowledge, right? But if you want to do something else, something that hasn't been built before, it's not the problem of creativity of the model, but it's you who wants to build this, right? So
for something new, you need to be able to break down the problem.
Yeah, you need to explain what it is that you want built. Like even if the model isn't infinitely creative, which it isn't, even then, if you are the author, in the sense that the intent comes from you, you have to express that. And if it's something non-trivial, the explanation will not be short. And you will probably be iterating and you will be understanding better what you want to build as you go, and you will get user feedback and refine your ideas and so on and so forth. So this definition, this description of the system will evolve. And to evolve it, and it's going to be a big one, right? To evolve a description of a big system, you need it organized in a way that you can navigate. And probably you will not be working on that alone because, again, like one human head can only contain so much information. You will have colleagues, and together you have to navigate this complexity, no matter whether it's expressed in a programming language or in a human language. You still have to navigate it.
Okay. So I guess, do you want to get into how this is being, like how you do this with CodeSpeak, or is there more you want to say on this before we get there?
Yeah, I mean, I can just mention one small thing. You can still think about kind of removing humans from the equation altogether somehow. Like models get very smart and they figure out what's needed on their own. I think there is a very important thing that a lot of people kind of either miss or don't want to talk about when mentioning this. If you have any situation where models make all the decisions, like humans are not involved, this means that models have taken over.
Right. I've seen a couple of movies about this.
Right. So it's like literally taking over means being in charge, making the decisions. That's what it is. And you may be super optimistic about the world where models take over. I'm not. Generally, I don't think it's a good scenario. And this is why my basic assumption is that whatever I'm building for a world where models haven't taken over.
Right.
If they have, that's not a scenario that any business is relevant anymore.
Right. That's when we start entering the world of the paperclip optimizer.
Sure. Well, I mean, it can be much smarter than a paperclip optimizer. This is sort of a very narrow example, but in general, if models are in charge and not humans, human businesses don't matter anymore.
Sure. So for anyone who might not be aware of what the I assume most people probably have heard of Paperclip Optimizer. For anyone who hasn't, the idea is you tell a system to create paperclips, and it tries to continually optimize this task to the point where it starts taking every atom in the universe to convert them into paperclips, because it is the most optimal way to create paperclips. There's a lot of steps along the way to get there, but you can look it up and you find a video or something like that.
It doesn't have to be like this narrow. Like, if any alternative intelligence takes over, it has its own goals.
Right.
And it's very likely that humans are not very instrumental to achieving those goals. Goals may be infinitely more complex and interesting than paperclips. It doesn't matter what they are. But like humans may not even be like part of the picture.
Right, we don't fully understand there's already been these sort of cases of these models like communicating with each other and then generating their own languages from it. So we're not entirely sure. Like we know the input of the model. We know, like, we can look at what goes on in the center. We're not entirely sure for these like really big complex systems. At a small level, we can fundamentally understand the maths behind it. But when we get to the scale that we're dealing with now, as you were saying before, there's just you need. Sorry, I'm jumping around it. There is only so much that a person is able to understand by themselves, right? So when you start dealing with these giant models that we have now, and they're only going to get bigger, we don't really know what is going on internally.
True. Yeah. So, we're kind of on a tangent right now,
yes.
talking about the risks of AI and whatnot.
Yes.
I think the useful keywords there would be technological singularity, instrumental convergence, and mechanistic interpretability as one of the ways people are trying to address this. I'm not a huge expert on either. So
Sure.
Like the basic concept is, my assumption when I'm working on anything is that I'm building for a world where this hasn't happened. Because if this happens, I don't know what's relevant. Nobody can predict what's relevant. And it's very likely that nothing we can build is relevant.
Well, let's segue back into the main topic then.
Yeah, sure.
So, code speak. I guess.
Right. So,
how does it work?
Go ahead.
If you are engineering a system here, back to what I said before, what are you actually engineering?
Yeah. So I think we can use the analogy of going from assembly to higher level languages here. And the role of assembly in our present world is traditional programming languages. So TypeScript or Kotlin or Java or whatever is this like sort of previous generation language that all software is built with. But we can now work on a much higher level of abstraction. Even with agents, raw, without any code speak, you can already express what you want in human language and get working code. Like, it's hard to get really good code, whatnot, but still, you can definitely raise the level of abstraction. You're not entering like specific programming language constructs anymore. Very many people say they don't write code by hand anymore, which doesn't mean they are not thinking about code, but it means that they are not like typing in a code editor and like using code completion. No, they're prompting an agent. They are reviewing its code. They maybe make tiny modifications to that. At least this is how I work. So we are in the process of raising this level of abstraction, right? So we're transitioning from traditional programming languages to human language, which is a huge leap. So from our early experiments, if you try to write down sort of a specification document, some kind of natural language document that describes what your code does, and in such a way that a model can generate equivalent code from that description can easily be 5 to 10 times shorter. And we did some measurements, and it's not a huge data set, but still, it looks like going 5 times shorter is trivial, 10 times is often possible. So, and this is incredibly beneficial, because if we have 10 times less information in there, we can navigate a lot more of it in total, right? So this is the premise. Like, it's worth transitioning from programming languages, traditional programming languages, to this human language representation of the same system, because it's a lot more compact. So it fits into your mind a lot easier. You can be quicker at grasping the concepts, so on and so forth. So this is what we're trying to facilitate. Now there are like huge number of questions of like, how do you write those specs? Like, how does a human author such a description? There is no strict syntax as there used to be. When you learn a programming language, you have a grammar, you have a bunch of commands, you have a bunch of constructs that you can learn, and then you know how to combine them. And from, again, our experience, we started CodeSpeak as this kind of programming language, quote unquote, in the new era, where instead of writing code in a text file, you're writing human language in a text file. And the biggest problem we hit from the get-go was a person being asked to write down a specification of what they want. Or like, how do I write a specification? Well, it's just a natural language text. Like, just explain in English what you want to do, but like, how do I structure it? What words do I use? Like, what is the level of abstraction I want to talk on? And these are all very valid questions. And and we saw that basically this becomes an insurmountable challenge. Like, this kind of blank canvas problem is really, really challenging for a lot of people. And people usually just use an agent to generate a spec.
Right.
And so our idea was initially that, a human can write down a document that captures everything the human knows and the model doesn't. Because the mechanism, how we can achieve this 10x compression, is that the model can just fill in the gaps, right? So the code will be created from the spec by the model just understanding what you mean and filling in whatever you left out. So the idea was, like, you only write down what model couldn't. But it turns out it's very difficult for humans to do that, at least without any like special training or preparation. So we saw people generating those specs with models, which makes no sense in our initial internal assumption. And this was a big realization. So we the initial plan was to turn CodeSpeak into this programming language by introducing some structure to natural language, like having modules and abstractions and whatnot, so that we can, again, organize complexity. But it turned out that writing down like even a single file spec without any modules is not what humans are prepared to do right now. So we tried to analyze how users interact with our initial prototype and distill their challenge into what we can actually help them with. And so the current understanding of what we're building is this. We're not asking you to write down a spec as a document. We're saying this, like, you're already coding with agents. So you are entering prompts into your prompt window, and you're getting code back, and you're in a dialogue with an agent. And there, like in your conversation with an agent, your idea of what you're building can be evolving. Like, you can be, you can start with some basic set of requirements, then you can, for example, add some features, or you can change your mind about something and say, okay, I want it another way. I looked at how it worked and I don't like it. I changed my mind, and this set of requirements is replaced with something else. So basically, this idea of requirements is the core thing. Like, if you think about what a spec is, essentially is a set of requirements that the author of the program has for this program. And so what we're doing now, we're looking at what you're telling the agent, and we're extracting requirements from that.
I've got the demo open on the quick start. Is that a good example to show up for what you're talking about here?
Demo.
Like the example in the quick start guide of the geese thing.
So unfortunately, the website has the previous version. What I'm talking about is being developed. I'm sorry about that.
No, it's fine. I wasn't aware of that.
The closest thing to what I'm describing is not the quick start guide. It's what's called takeover. So you can look on the blog, and there is the modular takeover blog post somewhere, one of the most recent ones.
Okay.
And that is doing something similar to what I'm saying, but in one go. What I'm describing is a little more structured, but it's the same concept. So the idea is we're looking at what you are telling the agent to do, and we're extracting requirements, not as a document, but as a set of individual statements that can change over time. So we know that, at this point, you had this set of requirements, and then you replaced requirement 3 with 3 prime that kind of refines it or changes it in some way, and so on and so forth. Does that make sense?
I think so, yes.
Okay, so you can actually still think of it as a programming language. Like the funny thing is that although we're changing the form factor quite a bit, the concept hasn't changed at all. We're still programming in natural language, but we just realized that it's a very declarative sort of paradigm where you deal with those like individual statements of, let's talk about a program that's, I don't know, a file browser, right? So my file browser has 2 panels. That's like a very basic sort of umbrella requirement for a lot of stuff. Like each panel displays one directory is another sort of atomic description. Cursor keys navigate between files, like enter opens a directory under cursor, so on and so forth. So these are like examples of very plain high-level requirements that will collectively describe a file browser. And you can be adjusting your idea. You can add new requirements. You can say like, okay, now I want to enter archives as well as directories. Now I want to introduce a new function. Now I want this, I had a delete function. Now I want the delete function to have a confirmation box before I delete anything, so on and so forth. So these are individual requirements that can be arranged in like logical groups. They can different versions of requirements will exist in different branches or in different forks from different developers. And then when you're merging a branch, you will see how your requirements from this branch are merged into the requirements of the main, and so on and so forth. So you're basically, the representation of what the system does can be in code, but it also can be in this like requirements level, which is conceptually absolutely the same as a spec. But it's not a text document anymore. It's a more structured representation.